Hello everyone, this video is a quick tutorial on some of the basics of SAS, getting used to the syntax as well as some of the more frequently used functions. So in this video we're going to be importing some data, finding some descriptive statistics about the data, making some plots, and then we're going to wrap it up with some analysis about the data as well. Alright, so starting off, right now we're looking at the code screen. This is where we're going to be writing our program. Later we'll see the results screen and an output screen as well. So without further ado, we can go ahead and start. Alright, and so with our first line of code, data, exam1, then ending with a semicolon, we see that we have this data function. So this data function tells SAS that we are reading or modifying a data set, and then exam1 is actually the name of our variable. And then with every line of code in SAS, we always end with a semicolon. So this next line here is telling SAS that there's going to be data being input as well as how to input the data. So this in file is telling SAS to input. The data lines is telling it that we are inputting it manually, and the delimiters is telling SAS how it's structured. So in this case, tab delineated, because we're going to be copying and pasting it from an Excel sheet. So the first of these two lines is telling SAS that there's going to be two variables within the dataset, grades and genders. The $ tells SAS that genders is a categorical variable. Then our next line, data lines, tells SAS that the following lines of code are going to be our hard-coded data. And so since our data is actually hard-coded, we can head over to Excel and copy and paste. And when you copy and paste from Excel, the default option is that the data is tab delineated. So you can go ahead and paste and then close that data with a semicolon. And then with SAS, it's best practice to close every function with a run command. So if we go ahead and run this, we can see that it has input the data. And here we're on that output data tab. Clicking back over to the code tab brings us to where we can write our next statement. So our next line of code, proc print. Proc stands for procedure, and that's telling SAS that we're going to be processing data. Print is to obviously print, and then data equals exam1 is telling SAS which data set to print, and then we're closing that off with a run function, and then highlighting and running. Here you can see a nice, visually pleasing table. Alright, so back at the code screen, we can see here we have a new command, proc means, which is going to deliver the means and some more descriptive statistics about exam1. We're going to further specify that we want it in terms of variable grades. Then we close that off with another run statement, highlighting it all, hitting the run button. We can see that we get a bit of descriptive statistics for specifically the variable grades. Heading back over to the code section, we can see that we can modify that means function a bit further. So here you can see that we've added n, mean, std, min, max options to our proc means function. This allows us to get the number of observations, the mean, the standard deviation, min, and max of our data. Again, we use that var grades function to indicate to SAS that we want the statistics based on the variable grades. Then we use class genders to tell SAS that we want those statistics broken out by the categorical variable genders. We close out our function with a run command, and then we can go over and highlight our function. Go ahead and run the code, and we can see that here it's broken out by the two genders, and we have that 5 or 6 number analysis for the two groups. If we wanted to find a 95% confidence interval for the mean, we would use a very similar code to last time, except we're going to add modifiers alpha equals 0.05 and CLM. Again, we use var grades to indicate to SAS that grades is our response variable, and class genders so that way we can find a comparison between our two categories. Close it out with a run and a semicolon, highlight it to run, and there we see the summary statistics for our two groups. So our next function, proc t-test, obviously is a two independent samples hypothesis test. We use class genders and var grades to indicate the categorical variable and response variable respectively, much like the means function above. If we highlight the command and then run it, it might take a bit of time because there's actually quite a lot of useful information in this output. So with the t-test function, you actually get quite a bit of output here. So you can see that there's a number of different descriptive statistics up top here, and then further below is a more in-depth analysis of the data, as well as information for the two different types of t-tests as well, that being equal and unequal variances. It also prints histograms of the data broken out by class, as well as QQ plots also broken out by the categorical variable as well. And next, if you want to run an ANOVA procedure, we would use proc ANOVA followed by the dataset that you wanted to use. The next line, class, grades, and genders, identifies which variables are going to be in our ANOVA model. We then use the line model grades equals genders to specify that grades is our dependent variable and genders is our effect variable. So running the ANOVA model, you can see that there's quite a bit of outputs. So that first section above gives information about the variables involved in the model. Then the next three tables feature information about the ANOVA model. Then lastly, there's a histogram featuring the distribution of the grades between the two groups. All right, another useful function is going to be proc univariate. Again, we're going to specify the data with that data option, and then we're going to use option plots. So in that way, there's a number of plots featured down at the bottom of the report. All right, and then we're going to specify that we are observing variable grades, and we're going to use option histogram grades to print out a histogram, obviously, of that grades variable. We're going to close that out with a run function. So this function actually allows for a lot of great summary information, as well as great plots to assess the data, including normality and discovery of outliers and such. So as you saw above, there's a lot of great summary statistics for the data, and then there's a number of plots printed down below, including a QQ plot and then this histogram plot that we had specified before. So as mentioned before, this function is a great way to investigate the data before analysis. So one of our last functions is going to be proc FREQ, short for frequency. Like many other commands, we're going to specify the dataset using that data option. We can conclude that with the run command, highlight it and hit run. And here you can see a frequency table of the different grades within the dataset, as well as the frequency per category, so male and female. However, in this example, it might be more helpful to separate the data maybe into, say, grades rather than just the scores. So we're going to create a new variable. So we're going to start off with data exam1 to inform SAS that we're manipulating that data set. We're going to say set exam1 to tell it that we're making a new variable. We're going to create a new variable called grade range and set it equal to grades. We can also create another variable here, grade squared, which is just the square of the scores as well. So we can actually use an if statement to create some of those categories. So if we use if grades less than 70, then grade range equals 1 to set all of the scores less than 70 to equal grade range equal 1. Similarly, we can group the next group by using if grades are greater than or equal to 70 and less than or equal to 79, then we can set grade range equal to 2. Again, we can do the same thing for the group 3 by saying if grades are greater than or equal to 80 and less than or equal to 89, then grade range is equal to 3. Lastly, we can set the final group by saying if grades are greater than 90, then grade range is equal to 4. Then, if we run that function, we see that we have a new variable called grade range and grade range squared. Grade range, obviously, are appropriate categories based on the grades variable. If we want to sort that data set using that new variable, we can use proc sort data equals exam1. We can add a new line by grade range, which is telling SAS to sort by the grade range variable. Then close it with a run command. Running that brings us back to our output data, where you can see that grade range has now been sorted from least to greatest. And then lastly, we can run that same frequency function as above. So proc freq and run that to get a frequency table. And we can see two new frequency tables based on our two new variables, grade range and grade squared. This you can see is very helpful to classify which scores students may have received. So that actually concludes our video tutorial. So if you have any questions about the code or anything, feel free to reach out.